Hello students, we are working on proportional reasoning, and today our objective is to use proportional reasoning to identify and find similar rectangles. So you guys had a rectangle sort yesterday in class, and today we're going to talk about what it means to be similar. And we went ahead and sorted our rectangles, and I'm here with my Core 2 Poke 7 class. And we're making this video for students who are absent today so that you guys can still learn what you need to learn. So let's talk first, and I'm going to ask for audience participation, and my audience is going to, or my class, is going to raise their hand. And we're going to go through some of the matches that we found for the rectangle sort. So I'm going to ask for volunteers to give me a match. And we're going to start with A. So which, oh look at, that's terrible, I have a messed up nail and I'm in a video. I'm going to hide my thumb. Okay. Alright, so I have an A. What rectangle did you find was similar to A? Mina? She says B. Okay, so she says A and B are similar. So what is it about A and B that would make them similar? Allison? Okay, so you're saying because the area of A when multiplied by 4 would give us B? Are there any other explanations? So these two are similar, but not for the reason that Allison said. So we're going to go ahead and write them down, and I'm going to tell you why they're similar. So we're going to say A and B. A and B are similar. She said because A goes into B 4 times. I want to hear a different explanation. That's not why they're similar. Because we could say that D goes into G twice, right? Does that make it similar just because it goes into it? No. So let's think about this a different way. Camilla? If A was bigger, it would be similar to B. So what you're telling me is they are the same shape, but not the same size, but different size. So for shapes to be similar, that's the definition. They are the same shape, but a different size. And then I want to talk to you about other things that are required for two shapes to be similar. What do you notice about the angles of A and B? So if I look at the angles of A and I look at the angles of B, what do I notice is true about them? What kind of angle is this? What kind of angle? Layla? Okay. Okay. So you're giving me something really important about the side lengths. So let's talk about that for a second. So she's saying that the side lengths of A and B, we'll go back to the angles in a minute. She said that she noticed that A was 2 and B was 4. And so the longer dimension of A is 3, and the longer dimension of B was 6. So tell me how that could prove that these are similar. Layla, continue. You said that was how you knew. It can, but that's not the reason why it's proportional. Let's look at the relationship between this side of A and this side of B. Think about relationships. We've been learning about proportions. So what's the relationship between the shorter side of A and the shorter side of B? Wilma? Yes, you could times 2. It's a times 2 relationship. The side length of A is double. I mean, if I double the side length of A, I get B. And what about 3 and 6? Is that also a times 2? Okay, so what could we say is true about the side lengths of A and B? They're what? They're multiplied by 2, which means they're what? We've been talking about this word a lot. They are, it starts with a P. Proportional. So in order for two shapes to be similar, they must have proportional sides. So whereas the relationship between the shorter side is a times 2 relationship, because 2 times 2 is 4, right? If we take this side here and we multiply it by 2, we get 4. And the same is true with the longer side. 3 times 2 is also 6. So do you guys see the relationship? We have the times 2, so it's proportional. What about the angles, though? What do you notice about the angles of these two shapes? What kind of angle do I have? What kind of angle is this? Julia? It's a right angle. What's true about all of the angles of A? All 4 are what? Right. And what about rectangle B? They're also right angles. So when we are looking at similarity in shapes, for two shapes to be similar, there are two requirements for them to be considered similar. They must have the same shape and different size, but 2 things. Number 1, angles are congruent. So the angles must be, that's your first check. And we know that all of these have the first requirement, right? Because they're all what shapes? What shape are all of these shapes? They're all rectangles, so we know all rectangles have right angles. So in this case, they all meet that requirement. But that's not the only requirement they must meet. What do you think the second requirement would be based on what we just discussed? So if we look back here, when we had A, and I said they were similar, not because one goes into the other, but why are these two similar? What's true about their sides? Lana? What's true about their sides? What are they? They're proportional. So I can look at the relationship between the shorter side and see it's a times 2 and apply that same relationship. Oops, I just put that the wrong way. And apply that same relationship to this one. And I see it's a times 2 as well. Okay? Questions on that? I think I had it this way, didn't I? There we go. Okay. All right, so what we're going to go back and do is look at it on the other side. And for them to be similar, angles are congruent and corresponding sides. So the long side with the long side, the short side with the short side, corresponding sides are congruent. Do they have to be the same? No, they're what? Proportional. All right, so what I would like you guys to do is I want you to go through now, and those of you that are listening will have to see me for the shapes later, but we'll go over it. The class is going to go ahead and make some more matches. Now that we know the correct definition for similar shapes, we're going to go back and see if we can come up with some other pairs using this definition. Desiree, Can I get you to pause the video, please? Okay, now the class has had a chance to look at the other shapes, and now that we know the definition of what it means to be similar, they came up with some other pairs. So we're going to start with C. This is our rectangle for C, and I want to know from the class, which rectangle do you think is similar to C based on the requirements that we talked about? So what rectangle would go with C? Mina? You think I. Okay, why do you think I would go with it? So C has 2 for the short side and 6 for the long. And then what does I have? What's the short side? That's not 2. What is that? It's 1 1/2. And then what's this side? 6. So if you look at the relationship between the long side, it's a ×1 relationship, right? 6 times 1 is 6 because it's the same. So in order for this one to be similar, it would also have to be what? It would have to be the same number as this one, which is 2. Shapes can be congruent and similar. They can be both, but these two are not. They're very close, but not quite. So these are not proportional. So let's try again and see if we can come up with one that goes with C. What's something that goes with C? Fatima? H. Okay, so tell me why you think H and C go together. Okay, because H, if I double the 1, I get 2. That's a ×2 relationship. Okay, so she's saying if the top of C, there's 6 for the long side, H, the long side of H goes into the long side of C twice as well. So again, we're looking at those proportional relationships. Short to long for C is going to be equivalent to short for long for H. So because those sides are proportional, C and H are the shapes that should go together. All right, let's go with D. So, or actually, let's go ahead and go up to our sheet. So we said it was C and H. And the way we know is the sides are proportional. So we know that 1 over 3 is equivalent to 2 over 6. So side lengths are proportional. Okay, so we're going to look at what shape goes with D. So I'm adding that to my sheet, and then down here I'm looking at my rectangle for D. What are the side lengths for D? What is the short side and the long side? We're going to label them. Wilma? 2 and 1. Okay, so what shape, what rectangle do you think is similar to D? Yasmin? G. She says G. Okay, let's take a look at G. What are the side lengths of G? 2 and 2. So if we look at D to G, we look at the short side. 1 to 2 is a ×2 relationship, right? So if we double the short side of D, we get the short side or side of G. And if I take the long side of D, What am I doing to 2? What's the relationship between 2 and 2? It's a times what relationship? 1. So this is a times 2. That's a times 1. So could they be similar? No. So let's find a different one. Camilla? Let's look at E. So E has a 2. Like I already, very convenient. It's already there. But then what is this side length here? That's a 4. So are those proportional? 1 times 2 is 2. 2 times 2 is 4. So D and E go together. So 1 over 2 for D is equal to 2 over 4 for E. Okay? So we can say that D and E are proportional because 1/2 for D, the side lengths, is equal to 2 over 4 for E. And again, our side lengths are proportional. Let's go ahead now and look at F. So let's look at F. So I'm going to pull that one up. And who thinks they have it for F? What goes with F? Sahar? You said I. So F and I, why do you think they're similar? Okay. Well, what do you notice about their short sides? They're the same. Are their long sides the same? No, they're not proportional. Because for this one, you've got 1.5. You've got 1, 2, 3, 4, 5. And this one you have 1.5. And you have 1, 2, 3, 4, 5. You have 6. So this is a 6. So this is a times 1 relationship, but this is actually a little bit bigger here. The relationship between the numbers is not the same. So what else could go with F? Look at your other shapes. What else? Find the shape. Julia? K. Let's take a look at K. So K has a side length. I'm just going to move it down here. K has a side length of 2 and also a side length of 1, 2, 3, 4, 5, 6, 7, 8. So is the relationship between 1.5 to 5 equal to 2 over 8? That's not an equivalent relationship, so it's not K. All right, let's see if we can come up with the other one. Which one should go with it? Layla? Maybe N. M? No, M is a square. No, that's not going to be right. So let's look at J. So let's look at the relationship between F and J. Okay? So we said already that the short side of F is what? What's the short side of F? 1.5. What's the long side of F? 5. What's the short side of J? Put them together in front of you so you can see this relationship. The short side of J is how many units? Everybody. What is the short side of J? 3. And what is the long side of J? 10. So let's look at the relationship. What is the relationship between 1.5 and 3? Times 2. 1.5 times 2 gives you the 3. Okay? You see the 1.5 to the 3. So now let's look at the relationship between 5 and 10. Is that also a times 2 relationship? It is a times 2 relationship. So what can be said about these two shapes? Their sides are proportional, so they must be what? Similar. So we're going to go up here to F and what letter was that? J. And we know they're proportional, and we're going to write our proportion. Our side length 1.5 over 5, which was F, is equivalent to 3 over 10, which was J. And again, we're looking at those side lengths. All right, let's take G. Take G, so take G and figure out which one goes with that. What shape goes with G? Julia? So she says M, okay? How could you prove to me that these two shapes are proportional? Side length of G is 2. It's 5. So the corresponding side, so the way they're lined up, 2 goes with 5. And then what about the other side of G? 2. And then this side of M? 5. So if we look at that in terms of relationships to see if it's equivalent, we have 2 over 2 and 5 over 5. Is that equivalent relationship? Yes. What's the way we can look at it horizontally? It's a times what? 2 times what is 5? 2.5. 2 times 2.5 is 5. It's the same relationship, but the other relationship that's pretty obvious, remember we don't just look at horizontal, we also can look at our vertical relationship. And what relationship do we have here? A times 1. Okay? So we're going to say that G goes with M because 2 over 2 is equal to 5 over 5. And again, our side lengths are proportional. So which two shapes do we have left that must be the matches? We have H, and H is going to go with what? What letter have we not used? Oh, I'm sorry, not H. I and K. Okay, so let's take a look at I and K. So I'm going to take I, and I'm going to take K. And what is the short side of I? No, it's not 2. 1.5 or 1.5. And what's the long side of I? What's our long side here? 6. What is our short side of K? 2. What is our long side of K? 8. Okay, so this one's a little more difficult to see, but 1.5 into 2. So let's look at this as a proportion. So 1.5 over 6, and we're going to see if this is equivalent to 2 over 8. This here, so we're going to look at the relationship between 2 and 8. Okay, that's an easy one to see. What is the relationship between 2 and 8? It's a times what? Times 4. Is 1.5 times 4 also 6? What's 1 times 4? 4. And then what's 1/2 times 4? What's half of 4? 2. And what's 4 plus 2? 6. So if I multiply 1.5 times 4, and if you try it on your calculator, you're going to see that you get 6. So these two shapes go together. So now I'm going to write on my sheet that letter I goes with what letter? K, because I have a 1.5 relationship. 1.5, the relationship between 1.5 and 6 is equivalent to 2 over 8. And again, the reason we're showing that, it's a times 4. And that tells us again that the side lengths are proportional. Okay, that's it for our rectangle sort.